Thank you. So I realize this is the last talk, so I'm going to try to make it lively, and I would like to get all questions from you about what I'm about to present. ESASky is a relatively recent project from the ESAC, from the ESAC Science Data Center, and all the people there have contributed to developing the software and giving science credit. In particular, I want to acknowledge Tony Marston, who has given us a lot of help on some of the things we want to show. Let me see. Okay, so this comes from a need. Sorry. So this comes from a need to rethink archives, how people will access data. So what happened is that we asked all the people. Are you getting the feedback loop? People there. Someone should mute probably. Yeah, can you mute someone? Ah, yes. Put that aside. Yeah, great. Thank you. So we essentially ask at ESA scientists, okay, so what would be your dream interface to search for astronomical data? And everything they said is encapsulated in this little word cloud, where the larger the size of the word means the more times it was pronounced or like mentioned. Of course, people wanted quick, simple access to the data, and then lots of other things later. We realized that we could improve that. So what we are working on is, what we have actually released already, is an application, web application called ESASky, which sits in this URL, sky.esa.int, that's operational. So I invite you to have a look at it already if you want. It's just a front end to all the science archives from ESA, and it will ideally make it easy for people to discover data sets and download them, and I'm going to demo this application to you very quickly. Our intention is that this tool will also connect to legacy products from past missions, currently live missions, and future missions. For example, now we still have in this slide the Gaia, because it was a future mission a few weeks ago, but now it's already there, and the intention is that this will always be giving you the latest, highest quality data, high-level products from all the ESA missions. The roadmap in terms of contents, data contents, which you probably want to know about, is essentially we've released this first release, which has all sky mosaics that I'm going to show you in a minute. These are progressive maps. You can zoom in to the pixel level or zoom out to the whole sky, and then access to science-ready imaging data for all these missions, and has point source catalogs for all these missions, typically from gamma ray to radio. The second release will be done, we hope, by the end of this year, and it will contain spectra, which currently we only show catalogs and imaging data. In terms of functionality, the version I'm going to demo to you allows a number of things. I'm going to show them to you. The important thing is that before the end of the year, because you could say, why is this guy talking us about an archive? The important thing is that one of the features we are developing and will be operational before the end of this year is the possibility to overlay footprints of any mission, any observatory on top of any part of the sky. You will see how that works. And we think this could be a very powerful resource for all of you working in JWST to make a quick look preparation of how you could plan your observations. Later next year, we will do some time domain set of features that will allow people to explore data as a function of time, which, as you will see, is currently not possible. So that's the URL. And now let me actually go and show it to you. So when you come to the application, what you see is, let me maximize this. You see a piece of the sky, and we need to put some welcome message to say, hi, welcome to ESASky, but we didn't have the time for it. This is a progressive map, so if I can zoom in or out, and it's very fast, as you see, because these maps have been made such that they are light in memory. So we see different resolution levels. But the nice thing here is that you can also come to this little menu on the top left and say, okay, I want to see this exact part of the sky in soft X-rays. How does it look like? This is how it looks like. And I can put this map on a stack and say, okay, how about UV? Is there any view data? Yeah, there's UV data there. All these maps are progressive. So if I zoom out, I will be able to see just that galaxy or the few degrees around or the whole sky. I'm going to show you that to you later. I can look at also near infrared. You see, even if it's called ESASky, I mean, we use this to help people finding out, discovering ESA data, but there's so much good data, of course, out there, that we're really trying to put everything that we think is really useful for scientists. So we have, of course, 2 mass and everything that we consider scientists need. This is a really science-driven approach, and we want to hear your feedback on that as well. So here you see I'm just kind of uploading like a set of tiles, a little sky, and then here we can see this object from soft X-rays. If I click play here, it's going to show me this object or any other part of the sky at any other field of view size in all these wavelengths in just a few seconds without having to know anything. So that's nice for visualizing. If you click on the play, it will actually scroll through them. But there's more than this, because of course you're all very, you probably want more of this. This is just, it looks like just visualization, but it's actually a lot more. So if you open this data panel down there, what you have is these 2 nice little histograms, which are the result of our software querying all the databases in all the individual archives for data in this exact rectangle of the sky. And it's telling me, okay, on the imaging observations, if I hover my mouse on the soft X-rays, which you see is physics. I mean, we have avoided, where possible, jargon from missions, because we know users hate it. We love it, but they hate it. So we've tried to, simplify as much as possible this interface. This is meant to be, easy to use. So in the X-rays, if I hover, it says, okay, something called XMM Newton has 6 observations. If I click, I get a little tab and a few blue footprints highlight there. I can identify which one I'm looking at by clicking on these little arrows. I can click on this little magnifying glass, and I'm actually looking at the postcard, which is a PNG from the XMM archive. So this is actually coming from another system, not ours, but it's still part of the ESDC. So I can also look at the UV, and in the UV there are a couple of other images which are outlined in purple footprints. I can do the same with optical, and in optical I see there's 1,089 HST observations. And this is funny because HST has been running for already 26 years. Wherever you go that it's interesting, there are a lot more HST observations than anything else. So the way to navigate here through that is just to be able to, you can switch on the legend. By clicking on the legend, you activate or deactivate missions you query on. Here, again, is the same thing. You can look at you can select some of them. The footprints get highlighted in white, you see there. You can get a quick look to the postcard, which in this case comes from the Hubble archive at ESAC. And you can actually download any of these files. So I can grab this one because this is all science data. I can directly click here and download data product. I get it, automatically it's open on my DS9, and that's the file. That's science-ready FITS files. And ESASky, we have all this debate with the mission specialists to say, okay, you tell us what is exactly what you need to, what you would give to a non-specialist. Just one single file per observation, please. And this is what we're putting here. And it's very nice because then at least you can actually have a quantitative science-ready X-ray image of that part of the sky. Same goes with Hubble. No, you see I haven't registered or anything. I'm just clicking on observations and downloading the FITS files directly. I can also look at Herschel. Herschel observed this galaxy as well. So if I select, for example, this one, large square, I can have a look at the preview from the Herschel archive, or I can download it. Okay. And this is essentially what would allow you to actually go and very quickly inspect data. So I've just downloaded this Herschel file. I just need to unpack it. And here you go. Now I have an X-ray and an infrared image of that galaxy, so I could go and compare them quantitatively. This is science data. Now there's more. I can look for coordinates. So let's go now to another target. This top right thing is there's a lot of code behind that little window. It really works a lot to figure out what you're looking. I go to M82, and now I look into in the other histogram, source catalogs. And this is telling me, okay, that's the same. It looks for catalog sources in this rectangle of the sky, and it tells me, okay, in the hard X-rays, there is something called integral. This is a gamma ray observatory, and here you go, you have the source, and you have in the tab, you have its the flags and flags that we consider important, or mission specialists consider important. I can also, for example, overlay X-ray sources on top of this image. And I can very quickly compare it with the actual X-ray image, which I have here, and you will see that the sources actually match pretty well what you see. We have the same, we also have, for example, I can put on, for example, since you are probably all people who like a lot HST, I can show you, for example, the ACS image of this galaxy. I can zoom in a little bit, because there are so many, and this will, you see, every time I change my field of view, the whole count of everything is updated, because it searches again. I can click on the Hubble source catalog, which as you know, was released, and there you go. There you have all the sources with all the magnitudes here. We will have a Herschel point source catalog soon. There's the Planck catalog. So how many of you did know that there is a lot of very nice catalogs, ESASky catalogs, or infrared submillimeter sources from Planck? Well, not so many. So here they are. The goal of this is that it will make it easy for people to discover all these products. Okay, there's more than that. You can also, because we know you like to work with target lists, you can come here and actually say, well, fine, but I just don't want one single file. I want to look at all my objects, and I have a large sample. So let's say, you know, I want to upload my target list. Okay. So this is just a very simple text file. So I have my target tree here, with just an ASCII file with a couple of names of objects and a couple of coordinates. It's flexible. We are working on really making this something you can use. So now the application sends all the names to a Simbad, gets all the coordinates back, and it's going to display a little list there with all the sources, and I can start navigating to them. And it will do every time I come to a source, it will show the source, and it will search for all data around all the sources there. And these source lists can be as long as a few hundred sources. We need to work on ways of doing this possibly faster. Also, something else, while that is loading, something else that I wanted to show you is that because these are progressive maps, I can come here and, for example, zoom out and say, okay, what if, if I really zoom out a lot, that galaxy is not visible anymore. I hope this is hardly visible. But now you can say, okay, so what's the XMM distribution? What's the distribution of XMM X-ray observations in the sky ever? I can refresh my tab of XMM observations, and instead of showing you the few thousand observations that XMM did with all their detail, we show a simplified coverage map. That's what we're showing here. Showing global sky coverage. It's a very light memory simplification of all the footprints, all the observations ever done on that wavelength. I can repeat this in purple with the UV data. Now in yellow, that's all the HST, all these yellow points, HST observations ever done in one single map. I can do the same with the Hubble, with Herschel. So now you get all these yellow footprints, that's all the observations Herschel ever done, etc., etc. And you see it's very interesting when you look at that. This stripe here is the galactic plane that Herschel observed in a large program. And you see all these patches. There are interesting regions that many observers over the last decades have observed with different facilities. Here you have them all. And you can do a different type of data querying, data analysis with them. And okay, so now we already got our target list here. If I click on one of the sources, the source will take me to that object, and it will adjust the zoom level such that I can actually see that source. And to go from one object to another is as easy as clicking on that little button. And if you're really even lazy to do that, you can click on display. Then you sit back on your chair and let the application give you a spiral galaxy tour on optical or in whatever wavelength you want to look at. And as you can see, the histograms, I mean, that's the nice part. What we scientists tend to like the best is that every time we go somewhere, this is searching for all the data in all the images, science-ready images, and all the catalogs in those positions. So this is grabbing you a lot of data, and it's really making it simple for you to figure out what's there. Okay, and you might say, fine, again, but why is this useful for us? Okay, it is useful because now we are working on, as I said, a version that will develop by the end of the year, where actually you can overlay footprints. So picture yourself, you've heard all these nice talks about all these instruments, this little small imaging MOS, SOS, everything else, and you need to, digest all this information. So we had always the plan to do, because everything is built in there, all the geometry, it's already built in the software, it's so easy to put footprints of future missions. So we thought, hey, why don't we do it with JWST? And that's what we have. But this is, I'm showing you now a development version. So what I can do now is, you see there's a new button here that is a little telescope, because it's like, okay, what if you would like to observe this with the telescope? Then you click, and it now currently just has JWST. In the future, it will have HST and XMM and all the other major observatories. You can click on any of the instruments, and it will plot the footprint, the precise footprint of that observation on top of your image, wherever you are. We are looking at M101 now, as observed with the SOS. So SDSS. So you can rotate it, you see, with just by clicking on these little arrows here, you can rotate it as much as you want, of course. This has nothing to do with reality that you will get with APT. It's just a quick look. There might be rotation angles that make no sense. You just can play with them very easily. So imagine, for example, I'm interested in some source like that one. Okay, I can rotate a little bit here, and then I can move this on right ascension a little bit. Okay, let's come here. Of course, I can zoom more. Imagine I want to put that source in the IFU. You see, it's very easy. I come here, I move it a little bit. Oh, you see, it's a development version, so sometimes we still have issues with the positioning. But I can come to that position, put the IFU aperture on exactly on top of it. I can then go and say, okay, but do I have a HST image of this? Yes. Okay, is it still there? Yes, it's still there because it's progressive. You can zoom as much as you want, and you have all the apertures. You can do this with just near spec, with any of the other instruments, and nice also is that you can do it with a whole set of footprints. So imagine you want to, make a parallel mode observations. Okay, there you go. You can put the whole set of instruments, and then you can figure out how to arrange your parallel mode observations. If you want to get near infrared and mid infrared imaging, there you have the instruments. You have the FGS there. You have nearest. You have everything you need in one single interface, which costs you nothing. Once you are happy, you can get the central exact position of what you were playing just by clicking on this little icon there. You can grab the central positions and use them for doing your real work with APT. Okay, so that's why I'm giving this talk in this conference. This is, as I said, it's not there, but if you go to this question mark here, we have the help page, some video tutorial, and there is a newsletter. So if you're interested to know when this is going to be online, which is a couple of weeks from now, just register to the newsletter, and we'll send, every time we update features, which we do constantly, or add new data, for example, the Gaia catalog is already there, we'll send a newsletter saying, this new data set is there, and eventually in a couple of weeks, we'll say, JWST footprints overlay feature is there, go test it. So we're just finalizing with the help of Tony to, make sure everything is perfectly consistent with the SIAF, but it will be there, so just register. And I think that's everything I wanted to tell you. This is just the same slide saying what I just said. There will be this nice telescope button where you can do some quick look preparation for your proposals, and that's it. Thank you for your time.